Yeah, good evening, class. Good evening, online students. Online students, good evening.
Good evening, ma'am.
Good evening.
Good evening.
Good evening. I've shared my screen. Is it visible?
Yes, ma'am.
Yeah, thank you. Yes. So I have already shared some images on WhatsApp, and I had instructed all of you to complete the same. I'd sent a bunch of questions and their answers on WhatsApp, and the instruction was to complete the same in your tuition notebook to whatever extent you understand the working. So today I'm going to explain all those answers which I've shared on WhatsApp. All right. This first one is already done, but not completely, right? I'll just do it again. I'm not very sure, so I'll just do it again. All right. Maybe a little faster this time because you already know it. So a well of inner diameter, a well, don't bite your nails. A well of inner diameter 14 meters. So the inner radius of the well is 7 meters. The inner radius of the well is 7 meters. So this is about the well. This is about the well. Well is a cylinder. It's a hollow cylinder. All right. The radius of the well is 7 meters and the depth or the height of the well is 15 meters. The earth taken out of it has been evenly spread all around it. It is a cylindrical well. It's a right circular cylindrical well. Because you can see it, the mouth is circular. That's why we have the diameter or the radius. Now, when you build a wall around the mouth of a well, the mouth which is circular, then the embankment will be a hollow cylinder or a cylindrical shell. So I mentioned these two terms in the last class. It's called a cylindrical shell or a hollow cylinder. Hollow cylinder. Hollow cylinder again, where the wall is thick. Hollow cylinder, two cases we have. Hollow cylinder, we have two cases. One where the wall is thin, so there's only one radius. Hollow cylinder, we have two cases. Case one where the wall is thin, case two where the wall is thick. If the wall is thin, the internal radius and the external radius is almost the same. Okay. But when the wall is thick, the internal radius is smaller than the external radius because the wall is thick. The external radius will be the internal radius plus the thickness of the wall. Okay, so now the wall which is built around the mouth of the circular well will be a cylindrical shell or a hollow cylinder. You must have all seen it, how the wall around the well looks like. You all know it, right? You must have seen it definitely sometime. Okay, now the earth is used to build the embankment around the well. We don't know the height of the embankment. That's what we have to find. All right. So given this information, we have to find the height of the embankment. We also know for the embankment, the thickness of the wall is 7 meters. The thickness of the wall is 7 meters. The internal radius of the embankment will be equal to this one, 7 meters. The external radius will be R plus W, the internal radius plus the thickness. So 7 plus 7, 14 meters. So after reading the question, understanding the information given, you need to write out the solids you see in the figure. So here we have a well and an embankment. For the well, we only need R and H. We have written R and H. For the embankment, which is a hollow cylinder or a cylindrical shell, we have two R's, one inner radius, one outer radius, and height. So we have calculated the inner radius is nothing but the radius of the well. The outer radius is inner radius plus the thickness of the wall. And the height is not known. That's what we have to find. That's what we have to find. So let me call this H1 because we already have H here. So let me call this H1. So now what's the equation in words? The volume of the earth in the embankment, the volume of the earth in the embankment is equal to the volume of the earth that is dug out. The volume of the earth in the embankment, in that wall, the volume of the earth in that wall is the same as the volume of the earth which is removed to make the well, which is dug out of the well. This is the equation. This is what we understand. So now this equation in words must be converted to a mathematical one using the appropriate formula. Now, what did we say? The volume of the earth in the wall, volume of the earth in that embankment. What is that equal to? That formula is pi h into r square minus r square, or pi r square minus r square into h. This is the formula. This is the formula. Is equal to the volume of the earth removed from the well. The volume of the earth removed from the well is pi r square h. Is the volume of the well, which is pi r square h. Pi r square h is the volume of the earth which is removed from the well, is equal to the volume of the earth in the embankment. Embankment is a cylindrical shell. Now the cross section, this is recall. Cross section of a cylindrical shell is a ring. I've told you this. A ring. This is a ring. This one. This is empty. This one is not there. This one is called a ring. If you have many identical rings like this and you place them one over the other, when you have many identical rings like this and you place them one over the other, the solid obtained is a cylindrical shell or a hollow cylinder. So we understand that volume is area of the uniform cross section into height. That's how we understand volume. Volume is area into height. Volume is area into height. When a 2-dimension is given height, it becomes 3-dimensional. When anything that's 2-dimensional is given height, it becomes 3D. Square, it assumes some height. It can become a cube if the height is the same as the side of the square. But if the same square is given a height which is bigger or smaller than the side of the square, it becomes a cuboid. If a circle is given some height, it becomes a cylinder. Okay, so a circular ring like this, if this one assumes some height, that's a hollow cylinder. Volume is area into height. Area of this ring is pi r square minus r square into height, into h1. Pi r square minus r square is the formula to find the area of a ring. This we have seen in 8th standard. Area of a ring, area of outer circle minus area of inner circle. The area of the shaded region is equal to area of the outer circle minus the area of the inner circle. They'll give you a figure like this and they'll ask you to find the area of the shaded region. Shaded region is pi capital R square minus pi small r square. So when you take out pi common, you'll get r square minus r square. That's what is this? Area of the ring. Into height. If this one has height, it becomes a 3D. It becomes a solid, a hollow cylinder or a cylindrical shell. So pi r square minus r square into h1 is equal to pi r square h. So pi and pi on either side gets cancelled. Now substitute all the values and calculate, you'll find h1. See, now I'll not read and disturb you. So I'll just show you, you can just read it yourself. Or maybe I'll not disturb you at all. I'll just give you 2 minutes, go through this. Exactly what I explained is here. Pi on either side gets cancelled. That I cannot show here. So understand that. Next one. Find the number of coins. Find the number of coins 1.5 centimeters in diameter. So now I remember that I actually finished explaining that in the last class. Now when I come to the second one, I realize that, oh, that I already finished. Anyways, it was a recall for you. Now this also I finished, but I would like to do it again. Find the number of coins. So I told you, a coin is a cylinder. It's not a circle. A coin is not a plane figure. A coin, yeah, it has little height, no? So it's a cylinder. It's a right circular cylinder. Find the number of coins. Now for a cylinder or for this coin, what are the values you need to know? Radius and height. If you have radius and height, you can answer any question regarding this coin. Coin is a cylinder. And for cylinder, we need two values, radius and height. If you know radius and height, anything you can answer. And you have the radius and height. You can see that 1.5 centimeters in diameter. So you know the radius. And thickness is the height. The thickness of the coin is the height of the coin. 0.2 centimeters thick. To be melted to form a right. So some number of coins are melted and they're made into a right circular cylinder of height 5 centimeters and diameter 4.5 centimeters. So again, for the new cylinder, radius, height, both are given. For the coin, radius, height given. For the new cylinder, radius, height given. So the question is to find how many coins should be melted to get a cylinder of this radius and this height. If you want to get a cylinder of height 5 centimeters and diameter 4.5 centimeters, how many coins must be melted? So let n coins be melted. Let n coins be melted. So the volume of one coin, is, okay, see, this is the equation. Volume of all coins is equal to volume of cylinder. Volume of all the coins. I told you, when one thing becomes another, their volumes will be the same. So the volume of all these coins will be equal to the volume of the cylinder, that new cylinder. All these coins are melted. Now there are no more coins. They are melted. And now they become a cylinder. They are now of cylinder. So the volume of all these coins will be equal to the volume of that new cylinder. This is what we understand, correct? Something becomes something. Originally, what many coins were there? So volume of all the coins is equal to, what do they now become? They become a cylinder, is equal to the volume of the cylinder. Okay, so how do you find the volume of all the coins? Volume of one coin into n, into the number of coins. Volume of one coin into the number of coins. Supposing you have 10 coins, volume of one coin into 10 will give you the volume of all the 10 coins. So volume of one coin is pi r square h because it's a cylinder. Pi r square h into n. So this is the volume of all the coins. This is the volume of all the coins is equal to the volume of that cylinder. So now there are two cylinders in this question. So again, you cannot write pi small r square and small h. So you can use, pi capital R square and capital H. Or you can use R1, H1 on one side and R2, H2 on the other side, whatever. To differentiate. Because one cylinder is about coins. The other cylinder is about the new cylinder. So they're two different cylinders. So different radius and height. So you cannot use the same variable RH. Small letter R, small letter H, you cannot use. You should differentiate. So coin, I've used small r, small h. Cylinder, capital R, capital H. Or you can use R1, H1, R2, H2. Or you can use R and H on one side and R1 and H1 on the other side. So now pi gets cancelled on both the sides. So n into, what is the radius of all the coins? What is the radius of one coin? 1.5 by 2, correct? What is the radius? Diameter is 1.5. So radius will be 1.5 by 2 into height. Height is the thickness, 0.2, is equal to a radius of that new cylinder, 4.5 by 2. Oh, 2 times I should write, sorry. 2 times ms, right? So n into what? 1.5 by 2 into 1.5 by 2 r square into h is equal to r square again. R square is 4.5 by 2 into 4.5 by 2. Diameter into h. H is 5. All right. R square, no? So it will be 4.5 by 2 into 4.5 by 2 into h. Now calculation. So see here, children, n into shift the decimal. See, multiply the numerator and the denominator by 10. Multiply the numerator and the denominator by 10. So what is 1.5 into 10? 15. What is 2 into 10? 20. Shifting the decimal, moving the decimal point. நீங்க அந்த into 10 லாம் காமிக்க வேண்டாம். You don't have to show that. Just do it in your mind. Multiply the numerator and the denominator by 10. So 1.5 into 10. 2 into 10. Am I clear? Into 15 by 20 into 2 by 10. 2 by 10 is equal to, multiply the numerator and denominator by 10. So 45 by 20 into 45 by 20 into 5. Into 5. Now it becomes so easy, no, to simplify. When we have decimals, we might go wrong. We might go wrong. So never proceed with decimals. Convert them to fractions. Convert them to fractions. Now it's easy. You can simplify. So how do you simplify? 3s are, 4s are, 5. Just do that now, please. I think when it shakes in the wind, excuse me, online students. It's like putting a baby to sleep, you know. These toddlers, you rock them, and they sleep. And when you put them on the bed, they wake up. So it's like that now. No, yeah, let me take out this and yeah, that's good. Yeah. Thank you. Okay. So it becomes 3 by 4. Here also 2 1s are, 2 5s are, 5 9s are, 5 4s are, 5 9s are, 5 4s are. Then you know, how will you transpose? N is equal to what? 9 by 4 into 9 by 4 into 5. And all these will become reciprocals on the other side, correct? 3 by 4 will become 4 by 3 on the other side. 3 by 4, 4 by 3. 1 by 5, 5 by 1. It will be 9 by 4 into 9 by 4 into 5 into 4 by 3 into 4 by 3 into 5 by 1 or 5. Now cancel this. 3 3s are 9. Then 4 and 4, 4 and 4 gets cancelled. So 5 5s are 25, 25 9s are 225. So 225 coins have to be melted. So what I have done is I've converted all those fractions here itself. So you can do anyways. See it? I've done all that. I've done all that fraction converting. I've done it here itself. Radius is 1.5 by 2. Okay. Okay, I've written it as point. You can also do what I said, children. I said into 10 into 10, no? You can also do that. 1.5 by 2. 1.5 by 2, what did I say? Into 10 into 10. So it will become 15 by 20. So 3 by 4. I have written 1.5 by 2 as 0.7. What is 1.5 by 2? 0.75. Then 75 by 100 I've written. It all amounts to the same thing. So I've done all the fraction conversion I've done here itself. So I've directly used the fractions here. Here when I was explaining, I converted the decimals to fractions while working. Here I've already prepared all that. Converting decimals to fractions, I've already prepared it. So I've just substituted the fractions straight away. Not L be found. Let n coins be needed. Let n coins be needed. All right. How many of you finished working all this? Very good. Bye. Next class we'll finish. You? Bhavisha, you finished? Same school. Yeah. What about you? Argument? Finished. Nritya and Bhavisha finished it. And here, very good. Hariharan and you finished, no? Fully? Oh, you didn't finish, your friend. Okay. Mohit has finished. Okay. Very good. Mohit, Nritya and Bhavisha. Very good. Online students, how many of you have completed the assignment at shared on WhatsApp? Online students? Nobody has finished? Why no response? Children?
Ma'am, I have three sums left, ma'am.
Let's see 3 sums to go. Okay. What about Sadhana, Sabarna, Haripranav, Laksha, Aniruddhan, Swati, Sahana? Yes, one by one, tell me. Let's not waste time on this. Quickly. Haripranav?
Ma'am, till this have completed, ma'am.
Okay. Aniruddhan?
Ma'am, need to write 3 questions.
Okay. Swati?
Ma'am, I have completed till that well embankment question. I have to do others.
Laksha? Okay, she sent a message. All right. A solid iron rectangular block. A rectangular block is a cuboid. A rectangular block is a cuboid. A solid iron rectangular, iron is the material. Solid iron is the material. Okay. Rectangular block of dimensions. So what are the dimensions? Length, breadth, and height. Is cast into a hollow cylindrical pipe of internal radius 35 centimeters and thickness 5 centimeters. Find the length of the pipe. All right. So name the 2 solids, children. What are the 2 solids in this question? Cuboid and the cylindrical pipe. The cylindrical pipe. These are the 2 solids. Now for the cuboid, what do you need? Length, breadth, and height. Are they given? Yes. 2.2 meters, 1.2 meters, 1 meter. Okay. Now for the cylindrical pipe, see, when they say internal radius and thickness, that means the wall is thick. So you need the values of small r, capital R, and h. You need the values of small r, capital R, and h. See, because it's given, see, hollow cylindrical pipe, you might say this hollow cylinder is confusing. How do I know that if there are 2 R's or only 1 R? The wall is thickness 5 centimeters. That means there are 2 R's. Internal radius is given, then the thickness is given. So the external radius you can find. Okay. So hollow cylindrical pipe of internal radius. So R is equal to 35 centimeters. And W, thickness, is 5 centimeter. So capital R is equal to R plus W, which is 35 plus 5, 40 centimeters. All right. So for the cylindrical pipe, we need smaller capillary. We've got it. And we also need height. Length of the pipe is the height. Pipe is a cylinder here. Length of the pipe meaning height of the pipe. So H we don't know. You can call it H1 also because we already have H here. So you can call it H1. We don't know. And here you can see that every value here is in centimeter. But for the cuboid, it's all in meters. So you in one equation, on both the sides, the units must be the same. You cannot have meters on one side and centimeter on the other side. Okay, so now for the cylindrical pipe, we have everything in centimeter, but for the cuboid in meter. So we'll convert meter to centimeter. Always convert to the smaller unit, meter, centimeter. The smaller unit is centimeter. So we convert to the smaller unit. So 2.2 into 100. How do you convert? We are not shifting the decimal point here. We are not shifting the decimal point. We are converting 2.2 meters to centimeter. So we should multiply by 100. 2.2 into 100. 1 meter is equal to 100 centimeter. So 2.2 into 100, 220 centimeter. We are not doing this to shift the decimal point. We are converting meter to centimeter. So we are multiplying by 100. So 120 centimeter, 100 centimeter. Now, what is happening in this question? The cuboid is cast, meaning is converted. This iron, again, it's melted and it is converted to a hollow cylindrical pipe. The solid cuboid made of iron is melted and is made into a hollow cylindrical pipe. So one solid is converted to another solid. So their volumes will be the same. So the volume of the cuboid, L into B into H, is equal to the volume of the pipe. That's all. Volume of the cuboid is equal to the volume of the pipe, or volume of the pipe is equal to the volume of the cuboid. Why? Because the cuboid becomes the material in the cuboid now is in the pipe. All the material in the cuboid is now in the pipe. So the volume of that material will be the same in both. Now, normally what I write in the LHS is, what is that we have to find? The height of the metal pipe, right? So I'll write that volume of pipe in the LHS. Volume of pipe is equal to volume of cuboid. Volume of cuboid. Volume of pipe, whatever we have to find, I'll put it in the LHS. Anyways, it's fine, but I normally keep in the LHS, I keep wherever we have to find. So here in the pipe, we have to find the height, right? So I've kept the pipe on the left-hand side. Volume of the pipe is equal to volume of the cuboid. What's the volume of the pipe? Pi R square minus R square into H is equal to LBH. Okay, here this H1. So now substitute the values and so you can see here length, breadth and height I've converted. I've just used capital LBH. Anything, you can use small LBH. Then for the hollow cylindrical pipe, radius, small r, W, capital R, H we don't know. I've used LBH, capital. Since I've used a capital H here, I've not used H1 here. Volume of the iron in the hollow cylindrical pipe is equal to the volume of the iron in the rectangular block. Formula, substitute the values, and here I've used A square minus B square is equal to A plus B into A minus B. Mohit, it's on board. Okay, so pi h into r square minus r square is equal to L into B into H. All right, what is this? Volume of the cuboid. This is the volume of the cylindrical pipe. I've substituted the values. Then this is the a square minus b. The h is here. You can see 22h. A plus b, a minus b. Then 22h by 7 is equal. This is 75. This is 5. Now the numbers when it goes to the other side, h is, see this h is equal to all these numbers you must write. All this you should write. The 7 will go to the numerator. So 7. And that is the numbers here in the denominator will go to the numerator. All the numbers in the numerator will come to the denominator. 22, 75 and 5. All the numbers here in the numerator will come to the denominator. The number in the denominator will go to the numerator on the other side. Simplify and we get this one. So convert it to meters. So divide by 100. 2240 centimeter is equal to divide by 100. So it will be converted to meters. So 22.4 meters. Oh, I've written 2.24. Sorry. Did anyone find all these mistakes? 2240 centimeter. How do you convert centimeter to meter? By 100. When you divide by 100, you'll get what? 22.4. Please check on the calculation so you can let me know. See, I normally work a set of sums in a row, so I can make calculation. I do use a calculator. I don't work. I use a calculator, but still, I may go wrong. Calculation alone. Concept-wise, nowhere I'll mislead you. If I don't know, I'll say I don't know. But calculation, please excuse me. Rarely you can find mistakes. Not very often here and there. So please check the calculation. I don't know if it is 224 also. Maybe the answer is 224 and that's why it's 2.24. I don't know. That you have to figure it out. So I'll not say anything. Just check it yourself. Maybe this answer is 224 and that's why I've written 2.24. So figure it out. I don't know. Please cancel and check that. Next one. A hemispherical bowl of internal diameter 36 centimeters contains a liquid. Now here they're just talking about the internal diameter. They're not talking about thickness and all that. So then there's only one R. There's only one R. A hemispherical bowl of internal diameter 36 centimeters contains a liquid. This liquid is to be filled in cylindrical bottles of radius and height given to you. How many bottles are required to empty the bowl? So you should again figure out the equation in words. What do you have? You have a bowl full of some liquid. Okay. You have a bowl full of liquid. You have to transfer the liquid in this bowl into identical cylindrical bottles. You have a hemispherical bowl full of liquid. You need to transfer this liquid from the hemispherical bowl into many identical cylindrical bottles. How many bottles are needed to empty all the liquid in the bowl is the question. How many bottles are needed to empty all the liquid in the bowl? Say you're a pharmacist, you know how to prepare medicines. So you have prepared the medicine in a bowl. Okay, so you prepared the medicine in a bowl. Now you want to sell it. So you're packing it in cylindrical bottles. So how many bottles are needed is a question. Again, the volume of the liquid in the bowl will be equal to the volume of the liquid in all the bottles. How many bottles we don't know. This is the equation in words. Volume. The equation in words is volume of the liquid in all the bottles is equal to volume of the liquid in the bowl. This is the equation words. You must frame the equation in words. Only if you can do this, you can then replace this equation with the formula, substitute the values and simplify. So it's actually very, very easy. You just have to understand the question to write this in words. Now this is sensible, right? Volume of the liquid in all the bottles is equal to the volume of the liquid. From where did you fill the liquid into these bottles? From the bowl, right? So the volume of the liquid in all the bowl, sorry, the volume of the liquid in the bowl is equal to the volume of the liquid in all the bottles. Do you all agree with this equation in words? Now, how do you find the volume of the liquid in all the bottles? The volume of the liquid in one bottle into the number of bottles. How do we find the volume of the liquid in all the bottles? The volume of the liquid in one bottle into the number of bottles. So we don't know how many bottles. So N into the volume of the liquid in one bottle is pi r square h. It's a cylindrical bottle, so pi r square h. Pi r square h will give you the volume of the liquid in one cylindrical bottle. Into the number of bottles will be the volume of the liquid in all the bottles is equal to the volume of the liquid in the bowl. The bowl is a hemisphere and volume is 2/3 pi r cube. So you can use a capital R here. Because there's R here or R1. Because there's R here and here also. So just differentiate this. Yes or no, children? N into pi r square h is equal to 2/3 because hemisphere 2/3 pi r cube. So pi and pi gets cancelled on both the sides. N into what is the radius? For the cylinder, what is the radius? 3 r square, 3 into 3 into h is 6 is equal to 2/3 into r cubed. Diameter is 36. So the radius will be 18. 18 3 times because 18 cubed. That's all. Work this and you'll get the value of n. You'll find the number of bottles. You can see in this equation, there's only one unknown n. No. I'm not asking you to work. I'm just. Online students, please raise your hand if you've understood so far. Otherwise, you can ask me your questions. Whatever question you have, you can ask me. If you want me to repeat any explanation, please ask me, I'll do it. Okay. Here, children. No, there's no confident or yes, no will. ஏன்னா நான் உங்களுக்கு வந்து ஒரு அடி கொடுத்தா இல்ல 2 அடி கொடுத்தானா சரி 2 அடி why does following you know I'm not forcing you to say yes. I'm asking you. You understood, right? அப்படின்னா தான் I'm forcing you to say அப்படின்னா I'm forcing you to say yes. I'm asking you, are you following? So the answer can be yes or no. Understood? No, it's easy. Huh? I didn't say that. I'll let you know. Next one. So that's what you see here. See, in the next step, children, don't get confused. Pi gets cancelled. Pi is cancelled. So I have written n into r square h is equal to 2/3 r cube. Don't think this is the formula. This is the formula. Pi gets cancelled. You can directly write the step also. You can even ignore this. So here you'll write this. Okay. Okay, that you can take care, I think. You don't have to write this actually. You can directly cancel pi. You can cancel pi and substitute n into r square into h. You can substitute. Okay. A cylinder lies within a cube. A cylinder lies within a cube. So inside, so there's a cube, and inside the cube there's a cylinder touching all its vertical faces, and a cone lies inside the cylinder. If their heights are the same with the same base, find the ratio of their volumes. I hope I have the figure. No, I don't have it, so it's difficult to show. See here, I really cannot show the cube and cylinder inside, but I can just make you understand how it really looks like. So the cube, okay, I'll just show a square. This is a cube. Inside the cube, there's a cylinder. So the cylinder like this. I'm not going to succeed in drawing, but no, I can't do it. I can explain. No, I'm a very bad artist. I can explain. Imagine a cube. Imagining is very important. I can just browse the net, get the picture, and put it on the screen. I can get this picture now. Let me do that. All right. Yeah, so this is what it is. You can see it now. All right, so you can see a cube. Inside the cube, there's a cylinder, and inside the cylinder, there's a cone. Can you see that? There's a cube. Inside the cube. Now see the circular faces of the cylinder. They're touching all the four sides of the square. The surfaces of the cube. A cube has six square surfaces, right? A cube has six square surfaces. The top and the bottom faces of a cube are squares, and you can see the top circle and the bottom circle of the cylinder. They touch all the four sides of the cube. Can you see that? See the bottom circle. It's touching all the four sides of the square down. And see the top circle. It's touching all the four sides of the square. Why am I saying square? Because it's a cube. And you can also see that the circular portion of the cylinder and the cone, they coincide. Can you see the circular base of the cone? No, I can't see. I can see only one circular base. I can only see one circular base. But there are two solids there with circular bases. There is one cylinder and there's one cone. Then I should see two circles, right? So don't blink or rub your eyes. There's only one circle there because the circular base of the cylinder and the cone, they coincide. So that's what is given here. And their height is the same. The height of the cone, the height of the cylinder, the height of the cube, all are the same. Now let's read the question again. A cylinder lies within a cube, inside a cube, touching all its vertical faces. It touches all the vertical faces, the standing faces. The cylinder touches all the vertical faces. You should imagine that. Cube, vertical faces are like the four walls. Vertical faces are the four walls. The cylinder, it touches the curved surface area of the cylinder, touches all the four walls. It fits in exactly. It just fits in. If the cylinder is a little bigger, it will not get inside the cube. And the cone also. You can see the circular base of the cone coincides with the circular base of the cylinder. And these two circles, they touch all the four sides of the square. So now answer my question. If the radius of the cone is R, if the radius of the cone, online students, my screen is visible, right?
Yes, yes.
Yes, ma'am.
Yeah. Online students, my question is, if the radius of the cone is R, what is the radius of the cylinder? Online students. If the radius of the cone is R, what is the radius of the cylinder? Online students.
Miss 2R, Miss.
If the radius of the cone is R, what is the radius of the cylinder?
It's also R, ma'am.
That also will be R. Now, what will be the edge of the cube in terms of R? What will be the edge of the cube in terms of R? If the radius, yeah, 2R, correct. If the radius of the cone is R, the radius of the cylinder also will be R. This one is also R. This is also R. So this full thing is 2R. which means the edge of the cube is 2r. The edge of the cube is 2r. Don't use the, I'm not talking about x by 2. I'm not using all this. Don't see that x and all that. I'm not using the x that was already there in the figure. Forget this x and all this. I'm not using all these. My question is, if the radius of the cone is r, the radius of the cylinder also will be r. Then the edge of the cube will be r plus r. See, this is also r. R plus r, 2r. This will be 2r. See, the circle touches all the sides of the square. So the diameter of the circle will be the edge of the cube. The diameter of the circle will be the edge of the cube. So the edge of the cube is 2r. What is the height of the cube? Huh? What is the height of the cube? Online students, what is the height of the cube?
Two or
Correct. Blessy? Was it Blessy?
yes, ma'am.
Yeah. Why Blessy? Why is it 2r?
Because their heights are same with the same base, ma'am.
The height? Come again?
The height are same as the base, ma'am.
Okay, I think you mean to say that in a cube, the length, breadth, and height all are the same. Is that what you're trying to say?
Yes, ma'am.
In a cube, LBH all are the same. So if the edge of the cube, if this one is 2r, the height of the cube also will be 2r, no? Because in a cube, LBH all are the same. So what is the height of the cube? 2r. Then what's the height of the cylinder? 2r, because it's given that they have the same height. So what's the height of the cone? 2r. So we have found everything in terms of r. That's what you should do. You must find everything in terms of r. I'll write it for you. We have not still finished, so don't worry. I'm starting with the innermost cone. I said, see, the conditions are clear. Outermost thing is cube. Inside that cylinder, inside that cone. Outermost is the cube. Inside that cylinder, inside that cone. The heights are the same. Height of the cube, height of the cylinder, height of the cone, same. The cylinder, when you put it inside the cube, it just touches the walls and gets inside. There is no gap between the cylinder and the wall. The cylinder, the body of the cylinder touches the four walls, touches the vertical surfaces of the cube. You can see from the figure there. And you can see the circle, the circular bases, they touch the four sides of the square. That means the cylinder just fits into the cube. The cylinder just fits into the cube. If it were a little, meaning if the radius was a little more, it will not fit into the cube. It just fits into the cube. And the height is also the same. The height of the three solids are also the same. So we started with the radius of the cone. Radius of the cone. If the radius of the cone is r, what is the radius of the cylinder? R. So radius of cone r, radius of cylinder also r. Because their circles are the same. So this also is r. This one is also r. Now r plus r is 2r. So what is the edge of the cube? What is the edge of the cube? Online students, what is the edge of the cube?
2r.
2r. What is the height of the cube?
2r.
2r, because in a cube, length, breadth, height, all are the same. So 2r. Then what is the height of the cone? 2r. What's the height of the cylinder? 2r. Because all of them have the same height. So now We have cone, we have cylinder, we have cube. Okay. Now let the radius of the cone. Let the radius of the cone be r. So for the cylinder also, the radius is r. Now for the cube, the edge is 2r. The edge is 2r. So what's the height of the cylinder? 2r. What is the height of the cone? 2r. So now for everything, cube, we have written edge is 2r. For cylinder and cone, we need radius and height. So radius r and height is 2r. We have written everything, right? Now we have to find the ratio of their volumes. When you find the ratio, you should find the ratio in the same order the solids have been introduced in the question. In what order are the solids introduced to you in the question? Supposing now 3 students enter the class and I say find the ratio of their heights. So whoever comes first, that person's height is to second person's height is to third person's height. In whatever order they enter the class, if 3 students enter the class and I say find the ratio of their heights, in the same order they enter. Now, in what order are the solids introduced here? First cylinder was introduced, then cube, and then cone. So you must find the ratio in the same order. Find the ratio of their volumes. Order is very important. The order in which you find the ratio is very, very important. So the order is not given, but the order is the same order in which the solids are introduced in the question. So first came the cylinder, then came the cube, and then came the cone. All right. So cylinder, what's the formula to find volume? Pi r square h. Pi into r square. What is r square for the cylinder? See, substitute. What is that? R square into h. H is 2r. H is 2r. For the cylinder, pi r is r only, and h is 2r into 2r is to cube. Cube volume is side cubed. So 2r the whole cube. Is to cone 1 by 3 pi r square. R only it is r square into h into 2r. So it will become, now if all the 3 had pi, we can cancel them. If all the 3 had pi will get cancelled. But for the cube, there is no pi. So you have to use 22 by 7 here. If all the 3 had pi, everywhere you can cancel. But now you cannot cancel because the cube does not have pi in it. So you have to use a value 22 by 7. So 22 by 7 into 2 into r cubed, correct? 22 by 7 into 2 into r cubed is to 8 r cubed, because 2r into 2r into 2r is 8r cubed, is to 1 by 3 into 22 by 7 into 2 into r cubed. All right. Now r cubed is everywhere. R cubed gets cancelled. Gets cancelled. Now we have what? 44 by 7 is to 8 is to, what is this? 44 by 21. 44 by 21. Now that's it. We got the ratio. The thing is, we need to write it with, one second. Okay, so we got the ratio. We're done. So I'll just write it again. The ratio is 44/7 is to 8 is to 44/21. But the thing is, we don't want the denominator. We don't want the denominator. 1 minute. So you can multiply all the numbers by a common number. So the LCM of 7 and 21 is 7. So into 21 is to 8 into 21 is to 44/21 into 21. You can multiply all the three numbers by the same number, any same number. So what is the LCM of what do we have in the denominators? 7 and 21. What is the LCM of 7 and 21? 21. Multiply the three terms with 21. When you do that, you will get rid of the denominator. 7 ones are 7 threes are. You understand what I've done? Every term in the ratio I've multiplied by 21. Everybody, not only those terms that have 7 and 21. Don't say 8 does not have a denominator. Why you're multiplying that also with 21? Should do the same everywhere. Whatever you do, you should do for all. 44/7 into 21, 8 into 21, 44/21 into 21. All the three multiplied with 21. So the ratio is 2, 1 carried over, 132 is to, what is this? 168 is to 44. Now, can you simplify this further? Actually, I'm getting it like this because I could have cancelled 2 everywhere. I didn't cancel. I'll do it again. Now, simplify this by 2. Simplify this by 2, children. So you'll get what? 60. 66 is to 84 is to 22. Further by 2. 33 is to 42 is to 11. Actually, that's because I could have cancelled here. I should have simplified this 2. This 2 everywhere I could have cancelled, but I'll do that. So this is the ratio. The required ratio is 32 is to, no, forget that. The order is incorrect there. Then what order here? V1 I've taken cube first. We'll do this one. We'll work this one. So the order, you should always do the order in which the solids are introduced in the question. If it is given, find the ratio of the volume of the cylinder to the cone, some different order is given, then you should use that order. If no order is mentioned, you should always find in the order the solids are introduced in the question. Another way, okay, the other thing you can do here in this situation is you can also use the order in which the solids are placed here. Outermost is what? Cube. Then inside cylinder. Then inside cone. Yes, that maybe that order I've done here. That's also fine. That is also fine. In this case, remember this, whenever it is ratio, it is always, we will see in NCRT. In NCRT, I'll show you. Whenever we have to find ratio, you should find the ratio in the order things have been introduced in the question. That's what it is. That's a fact. That is a fact. In this question, because it's diagrammatic here, you can also find it in this order. Volume of cube is to volume of cylinder is to volume of cone, or volume of cone, cylinder, and from inside outside, cone, cylinder, cube, or cube, cylinder, cone. Or in this question, what order is there? Cylinder, cube, and cone. So here we have multiple situations like this. So in most probably in the exam, if you get this question, they should specify the order because you can think of multiple orders here. You can think of multiple orders here. Otherwise, it will be only one thing. Otherwise, it will be only one order. You will not get multiple orders like this. In the exam, most probably it should be given what order the ratio has to be found. If it's not given, it's better you ask your teacher. Because if she feels no, you should find cube, cylinder, and cone. So it's better you ask your teacher in which order you should find the ratio. Okay, so I did not simplify here, I told you, no. So let me simplify and then. So we got the same answer, except the order is different. 42, 33, and 11 it is here. Yeah, children. So before we yeah, we can cancel r cube, and you can also cancel 2, right? 2, 2 and 2 how many times? 4 times, correct? You can also cancel 2 4 times. 2 and 2 gets cancelled, and here 2 4s are 8. So what is remaining now? 22 by 7 is to 4 is to 22 by 21. Correct? Correct? I can still cancel. That's a problem. You can still cancel. See here, there's 22 here. 2 11s are 2 2s are and 2 11s are. I think now finally we've simplified. Now no more simplification. So finally we have 11 by 7 is to 2 is to 11 by 21. Yeah, now multiply by 21. 11 by 7 into 21 is to 2 into 21 is to 11 by 21 into 20. Why are you sleeping? 7 ones are 7 threes are. So 33 is to 42 is to this is the ratio. All right. Now we'll do this again. Very important question. Yeah, children. Oh. Since I didn't save it, the figure is gone now. I'm sure you don't want me to get it. So we'll now do it in the order from outside inside. So tell me what are the solids, children? Outside it was the cube, then cylinder, then cone. So radius is r, height is 2r. Then cube. Correct? Now volume of, what are we doing? Volume of cube is to volume of cylinder is to volume of cone is equal to h cubed. 2r the whole cube is to cylinder pi r square h, pi into r square into h is to 1 by 3 pi r square into h. 8 r cubed is to I said you should use the value of pi because pi is not everywhere. So 22 by 7 into 2 into r cube is to 1 by 3 into 22 by 7 into 2 into r cube. So cancel r cubed everywhere and also cancel 4 times. Write down till here, children. Write down till here because the other slide, write down this one. This one alone you practice now. Mostly this asked in MCQs. It's not even for 2-3 marks. MCQs. Yeah. So now let's cancel together. So, yeah, Mohit, tell us. We'll cancel all by 2. So what will happen to 8? 4. Here 2 and 2 gets cancelled. Then further, you can again divide by 2, right? So this becomes 2, this becomes 11, and this becomes 11. So you're left with what? 2. 11 by 7 is 2. 11 by 21. Now what's the LCM of 7 and 21? 21. So you multiply all the terms with 21. Everybody with 21. That's how we get the ratio. 42 is to 33 is to 11. All right. Yeah, so all these are similar questions. Now, most of you have not completed, and those who have completed also will be a revision for you. Do this. Read the question and tell me. What are the two solids in the question? Hollow sphere and cone. Okay. For the hollow sphere, what are the values you need? Internal radius. So you need the value of small r and capital R. And for the cone? Normally, what do you need for a cone? Huh? Radius and height. What did you say? Height and radius. Yeah, yeah. Height. No, this will be only volume, equating volumes. Okay, so you need radius R1 and height H. Now, what is R for the, what's the internal radius? Now, close your book, Mohit. Internal diameter is 4. So, internal radius will be 2. External diameter is 4, 8, 4. And what is the radius of the cone? 4. Height of the cone we have to find. Height of the cone we have to find. So what will be the equation? What becomes what? What becomes what? Hollow sphere becomes cone. Now what do you want to find? Height of the cone? No, you keep that in the left hand side. So tell me, volume of cone is equal to? No, in words, volume of cone is equal to? Volume of hollow sphere, that's all. Volume of cone is equal to volume of hollow sphere. Hollow sphere. Then what's the formula to find the volume of a cone? Online? Anybody online tell me? Volume of cone formula?
Yes, 1/3 pi r square h.
Very good. 1/3 pi r square h. 1/3 pi r1 square h is equal to what's the volume of a hollow sphere? Online?
4/3 pi r cube.
No. This one has 2 radius. Tell me. You're saying the formula like you're ordering something in the restaurant. I want one dosa. Yeah, completed. Then you're thinking, what shall I take?
Ma'am,
Yeah, completed.
Ma'am, 1/3 pi r cube, ma'am.
Oh, Anirudh. Anirudh, where are you? Sphere la irukom nama. Hollow sphere. 2 radius இருக்கு. அப்ப என்ன formula? அது
Pi
சொல்லு.
r minus small r square.
2/3 pi r cube minus 2/3 pi r cube. Small r.
Anirudhan, it is not 2/3. இது sphere, hemisphere இல்ல. ஹெமிஸ்பியர் இல்ல, ஸ்பியர் தான். ஆனா 2 ரேடியஸ் இருக்கு. Yeah, try again. Anirudhan, try again.
Ma'am, 4/3 pi capital R cube minus 4/3 pi small r cube.
Yeah, on taking common, what will you get? 4/3 pi. Yes, you are right, Anirudhan. 4 by 3 pi capital R cubed minus 4 by 3 pi small r cubed. 4 by 3 pi common எடுத்தா என்ன வரும் bracketல?
Ma'am, capital R cube minus small r cube, ma'am.
Yeah, very good. Now next what Anirudhan tell me? Next என்ன பண்ணலாம்? எதான் cancel பண்ணலாமா on both the sides?
Miss, you can cancel the pi. Miss.
Yeah, cancel pi on both the sides. Then something else you can cancel.
Miss 3, Miss.
Yeah, 3 in the denominator here and 3 in the denominator here will get cancelled. When you're cancelling on the same side, it should be numerator or denominator. When you're cancelling on either sides, LHS and RHS, both should be in the denominator or both should be in the numerator. When you're cancelling in the left-hand side and right-hand side, either sides, then both of them should be in the denominator or both should be in the numerator. On the same side, if you're cancelling, numerator, denominator. So 3 will get cancelled. Now substitute. What is R1? What's the value of R1? 4 into 4 into radius. 4. R1 square. So 4 into 4 into H. We don't know. Is equal to 4 into capital R cubed. 4 cubed minus 2 cubed. Yeah, children. No, even if you have worked it already, you can still practice it. Maybe those who've already done it as homework need not copy the questions. The others must copy the question and work it now in the class. Get started, all of you. Those who have already completed this as homework need not copy the question. Just work the answer again for practice. Those who have not done this homework, please write the question as well as work the answer. How much? Yeah, perfect.
Miss.
Yeah,
Miss, height is equal to 14 centimeter, Miss.
perfect. Very good.
Yes, Miss.
All of you got it? Such questions only you'll get for 4 marks. You need just 2 minutes to finish the answer. So read the question. The procedure is read the question, identify the solids, introduced in the question, write the solids, and write down whatever values you need for them. Like for cone, you need radius and height. For a sphere, in this case, you need 2 R's. So write down whatever you need. After that, write the equation in words. Then replace with the relevant formula, substitute the values and simplify. That's all. Okay. Yeah, do this. This I'm not helping you at all. Do this. Work this one, children. As I told you, those who have not done this assignment, please write the question and work the answer. Laksha. Who can tell me the equation in words?
Volume of the small spherical balls is equal to the volume of the whole sphere.
Correct. Volume of the
Volume of whole sphere equals volume of the small spherical balls.
Volume of all the.
Volume of the solid sphere equals volume of small spherical balls.
Correct. Volume of, yes. Now I want the equation in words clearly. Swati, volume of louder.
Now volume of the solid sphere equals volume of the whole small spherical balls, all the small spherical balls.
Correct, correct. Very good, very good. Yeah, which one I'll write in the LHS? What I have to find? The number of the small spherical balls, right? So let's write that in the LHS. So volume of all the small spherical balls is equal to volume of the solid sphere. A solid sphere is melted, so is equal to the volume of the solid sphere. So the volume of all the small spherical balls is equal to the volume of the solid sphere.
Miss,
Yeah,
Miss, the number of balls is 1000, Miss.
1000. Yeah, perfect.
Yes.
Very good. Hari Pranam, very good.
Forgot.
So how do you find the volume of all these small spherical balls? N into volume of one spherical ball is equal to volume of the solid sphere. Now substitute the formula. N into one sphere. What's the formula? 4 by 3 pi r cube is equal to 4 by 3 pi capital R cube or R1, whatever. N into, so don't think we are writing the same formula on both the sides, so cancel the formula. Not like that. This is also a sphere, that's also a sphere. So for same formula, cancel the formula. In the formula, the R is different. This sphere is small r, meaning the radius they're different. So here small r, there capital R, or R1, R2. So what will get cancelled? 4 by 3, 4 by 3 gets cancelled. Pi and pi gets cancelled. So n into r cube. What is the radius of each small sphere? 0.6. 6 by 10. Oh, diameter 0.6 by 2. 0.6 by 2. So it will be 6 by 20 or 3 by 10. 3 by 10. 0.6 by 2 because that's a radius by 2. Now into 10 into 10. 6 by 20 or 3 by 10. 3 by 10 into 3 by 10 into 3 by 10. R cubed is equal to 3 into 3 into 3. Correct? So you can cancel out all the threes. 3 here and 3 here gets cancelled. So when all these go to the other side, it will be n is equal to 10 into 10 into 10, 1000. All right, got it? Try this one. So spherical bullets are there and the solid cube. What are the two solids here? Spherical bullets. Spherical bullet and cube. Now for the spherical bullet, spherical meaning sphere. What is the radius? What is the radius of the bullet? 2 centimeters. What's the edge of the cube? 44 centimeter. Now, how many spherical bullets can be made out of a solid cube of edge 44 centimeters if each bullet is 4 centimeters in diameter? So we don't know how many bullets can be made. So that means there is one cubical block of lead. There's one cubical block of lead, and from that many spherical bullets are made. How many bullets can be made is the question. So the volume is the same. Volume of the cube is equal to the volume of all the spherical bullets. Volume of the cube is equal to volume of all the spherical bullets. So let n bullets be formed. Let n bullets be formed. Okay, I think you got it. Please work this. Now, what's the answer?
Miss 2541 Miss.
Yeah, Hari Pranav. Can you take a picture of your answer and share it on WhatsApp now, Hari Pranav? Is it possible?
Miss, okay, Miss.
Yeah. Not getting a 2541. Bhavishya, you got it? No? Behind? Mritsa? Aragamai? Got it? Not got? Come here. No, if you've not got, come and see what your mistake is. Okay, if you don't want, you can. Nobody's got it? Hariharan, Mohit? 85? Hariprana, when you're working, not here, you're put into instead of equal to. Just check. This place, no? It should be equal to. You're put into.
Okay, Miss.
And I think you can write more neatly.
Okay, Miss.
Okay. What? 2541? Huh? 2541. You found your mistake, Niveda? You got it? Ah. Okay. So now you got it or no? But you have the same numbers, huh? 44, 44. Same thing you have. Oh. What method? What is a different method altogether? Huh? Okay. Yeah, that's the next question. Finished? Yeah, what's the answer? 1,500. Oh, yeah, that's right. 1,500. Got the answer, online students? $1,500, correct. Online students?
Ma'am, 1,500, ma'am. 500, ma'am.
Correct. Very good. 1,500. 1,500 is the correct answer. So there's a cuboid here, LBH, and a sphere. I presented the answer, please check. The calculation part you take care. Now don't think you should get the same numbers. You should check only till here. You must check only, see, when I say check your answer, see, each one will calculate in a different, till here you should get the substitution correctly. Then after this calculating, see, maybe you have cancelled this 2 11s or 2 5s or so. This step might not match. Till here, till the substitution part. After this calculation will differ. And the final answer should be the same for all of us. Don't bother about this one. Check till here and then calculate by yourself. The volume of all the spherical lead shards is equal to the volume of the solid cylinder. I'm sorry, is equal to the volume of the rectangular solid. That is a cuboid. Volume of all the spherical lead shards is equal to the volume of the rectangular solid. So sphere 4 by 3 pi r cubed. N into 4 by 3 pi r cubed is equal to LBH. Yeah. Try this one, all of you. MCQ. There's nothing to work. Directly you can say the answer. Anybody can say? Online students? What should be the height? Ten. Because what is volume? Area into height. Area of the base into height is volume. Area of the base is 88. Into 10 is the volume 880. See, like actually it's like this here. L into B into H. LBH is the volume, no, is equal to 880. LBH is the volume. What is L into B? Area of the base. L into B is area of the base into height is equal to volume. Volume is area of the base into height. Volume is area into height. So volume is 880, area of base into height is 880. 88 into height is equal to 880. So height is 880 by 88, 10. Done? Finish writing, all of you? Okay, next one. Yeah. A square piece of paper of side 22 centimeters is rolled to form a cylinder. Just imagine this is not a square, this is a rectangle, but this is rolled to form a cylinder. It's rolled like this. It's rolled. It's rolled to form a cylinder. A square piece of paper. This one is rectangular. A square piece of paper is rolled like this to form a cylinder. To form a cylinder. Now we need to find the volume of the cylinder formed. So when you roll it like this, see what is, yeah, how much is this one? How much is this one? How much is this? 22, right? How much is this one? 22. And how much is the height? Height is also 22. Height is 22. And this one, because it's a square piece of paper, this one is also 22. This is 22, this is also 22. When you roll it like this, what happens to that 22? That 22 becomes a circle. That 22 becomes a circle. See here. Now that 22 has become a circle. That 22 which was like this, the 22 which was a straight, which was straight like this, is now curved. It, when you form a cylinder, when you roll it like this and form a cylinder, where did the 22 go? The 22 is here now in the base. The 22 is now here. So the circumference of the circle is equal to 22. And the height of the cylinder is also 22. Because this one is 22, this side is 22. So the height is 22. The height is 22. And where is that length 22? It's here now. It's become a circle. Because you've rolled it to form a cylinder, that length has now become a circle. So this one, this 22 is here now. When you roll the paper to form a cylinder, the length becomes a circle. The breadth becomes the height of the cylinder. In this case, the length becomes the length. Now, when you roll it and form a cylinder, the length becomes a circle now. The length is 22. Now that is now circular. So 2 pi r is equal to 22. That time it was L is equal to 22. Now that L has become 2 pi r is equal to 22. And what's the height of the cylinder? 22. Because the breadth is 22. The breadth of the paper is 22. The height is 22. So, yeah, okay, I have it here. So, see here, length of the circular base of the cylinder formed is equal to 22. The length of the circular base of the cylinder formed, that's the cylinder which is formed, the circular base, the length of the circular base is now 22. That means 2 pi r is equal to 22. When you work that, you get r. The height of the cylinder is 22. Because the breadth becomes the height. So now volume is equal to pi r square h. Find the volume. 2 pi r is equal to 22. From this you can find r. Okay, see, if you want some, you can just write like this. Length of the square, length of the square becomes circumference of the circle. Circumference of the circle. So the circumference of the circular base. Let me write it here. See. Yeah, you can write this one. Length of the square is equal to circumference of the circular base. So that means 2 pi r is equal to 22. 2 into 22 by 7 into r is equal to 22. 22 gets cancelled. So r is equal to 7 by 2 centimeter. Then breadth of the square is equal to height of the cylinder. Is equal to the height of the cylinder. So h is equal to 22 centimeters. Now volume of cylinder is equal to pi r square h. 22 by 7 into 7 by 2 into 7 by 2 into h. The answer is 847. So when a square or a rectangle or whatever piece of paper, okay, finish writing, finish it. That's so nice of you. Thank you. All right, children. So when a square or a rectangular piece of paper is rolled to form a cylinder, when it's rectangular, more information should be given. We'll see that in the next class. Now, this is a square piece of paper, so the length, breadth, both are the same. So when this one is rolled to form a cylinder, the length becomes the circle. Length is 22. So that becomes a circle now. That means 2 pi r is equal to 22. Not pi r square, not area. The length becomes a circumference. So 2 pi r is equal to 22. When you work that, you get the radius of the cylinder. And what is the height of the cylinder? The breadth of the square is the height of the cylinder. The breadth of the square is the height of the cylinder. So we get the height. So we know the radius, we know the height. Use the formula pi r square h to find the volume of the cylinder. Got it? All right, online children. That's it for today's session. Thank you so much. You can leave the call. Good night.
Thank you, ma'am. Good night.
Thank you. Good night. Thank you, children. Good night. Thank you.